Your agent's failing in production and you don't know why, but you also don't want to re-architect the whole thing from scratch. Today we're going to show you with ingest functions how to rebuild your agent with minimal amount of code changes possible and gain all of the durability that you need for a production run. Stay tuned to find out how.
Before we dive into the code, let's take a look at how this agent fails. So this is a really simple agent that takes in a prompt from our HTTP server. It has access to a single tool call that mocks a credit card charge. And if that tool call fails, the whole thing kind of falls apart. This is a pretty basic Anthropic SDK example. We'll go into the code here in just a second. So what that looks like is to mimic the tool call failing. I do have an endpoint that allows us to run the kill switch. So we're going to go ahead and turn the kill switch on. And then we have the run agent, which is going to call the agent. So we can see that our payment gateway timed out while charging the money, and there's no retry. We'd have to rerun this manually, and the agent call is done. If this got spammed and we tried to run it multiple times, there is a chance that the user would get charged twice because there's nothing tracking whether this worked correctly or not. And if we run it again, it's still timing out, and eventually we'll hit the end of that kill switch, and you'll see that now it is working properly. Let's take a look at this simple agent. So the first thing is we have a bun HTTP server that takes in a post request at API/agent and calls the run agent command. In our agents file, we have a few simple things going on. That run agent function takes in a prompt and uses it to call the Anthropic client. Our Anthropic client has access to a block of tool calls that it can use, and each of them have an execute tool function that takes in the name of the tool. So let's go ahead and take this existing agent and turn it into a durable agent using Inngest. So we're going to keep the same API endpoint, but instead of this API call calling run agent directly, we're going to go ahead and replace it with an ingest send that sends the agent/run requested event. That's going to go ahead and trigger our ingest function on the other end. Now we need to modify our agent file. So the first thing we're going to do, just to satisfy some TypeScript requirements, is this custom type that I've made, but this is just a TypeScript oddity. The first real task we need to do is take our existing run agent function and add a new parameter in that takes the step as the parameter, and the second step continues to be the prompt. Finally, we can drop in a little bit of code into our call to the Anthropic client that looks like this. And instead of just directly calling the client messages create, we now call an await step.run, and we fire that same thing off. The last piece of the puzzle is wrapping our execute tool call function inside of ingest events. So how the architecture of this works is the agent, instead of calling the tool call function directly, is going to fire off an ingest event, and that event will run the tool call in a new durable function. We're going to replace our direct execute tool call with a little more code, and what that looks like is step.send event is the actual thing that's being fired by our agent now, and it's sending an event of trigger. And then this is the tool call name. It is then step.wait for event for the tool call to come back as complete. And that is the full main agent loop now. And that is the extent of the modifications we have to do to our existing code. There's just a few things we have to create to tie all this together. So the first thing is a really simple ingest agent. Just call it from the main ingest package. Secondly, we need to create an ingest function that takes in our agent run requested trigger. That's that trigger that we put into our HTTP server. So when someone calls the HTTP server, it just fires off this event, and Inngest will queue up this function and run it. You can see that the function runs the run agent function that we just modified that now takes in the step as well as the event data that includes the prompt. And finally, we need to modify our tool call functions. So for our tool calls, we have a map of all available functions. In this case, we just have one, but we're putting it inside a map so we can add more tools later. Each of those tool calls gets an ingest.create function with a name, a triggering event, And you'll notice we're using that same execute tool as our actual meat of the operation here. And then when the execute tool is done, it just sends a tool completed ingest event so that the original agent loop can continue running. What you'll notice is that we didn't have to modify very much of our original code, but now we have the agent running in its own durable function, and we have each individual tool call, no matter how many times the agent calls those tools, in their own individual functions. So let's take a look at what that looks like running in the terminal and on the ingest dashboard. Now that our agent code is running inside of the ingest execution layer, let's take a look at how this solves our original problem of the agent firing the credit card tool call, and when it times out, we lose all of our progress. So the first thing we need to do is run the ingest dev command, which runs the execution engine and the dashboard locally on our machine. And over here, we're going to run our agent at localhost 3000. Now we'll go ahead and run the same kill switch command and also the run agent command. And you'll notice that it created an event ID instead of immediately returning us the result. So let's hop over to the ingest dashboard and take a look at what we're dealing with. On the ingest dashboard, we'll see that we have two durable function runs for that agent call. The first one is our main agent loop. If we open the trace up, we can see that the call model step was initiated. The LLM decided that triggering the charge credit card tool was necessary, and we can see that the majority of the time in the trace is waiting for the charge credit card tool to come back before it finally does the last part of the loop, finalizes with the LLM output. The second durable function is our charge credit card tool call. If we open up the traces here, we can see that our simulated failures are all captured in these attempts, where we are simulating a payment gateway timeout, but after a number of tries, it finally succeeds. This is how you achieve durable functionality within your agent tool calls, because each of these attempts is retriable and memoized, so you don't have to worry about the customer being double charged either. And as we can see with the finalization, we have the output of a successful tool call after a number of failed attempts.
All right, so now you can see how easy it is to add an ingest durable function onto your existing AI agent and gain all the benefits with minimal amount of code changes. You can sign up today on ingest.com for free and test out the system yourself. Stay boring.